Okay, chemistry students, this is a quick review of how to do some of the short answer type problems that you're going to see on your exam. So these are the ones from our practice exam. And let's take a look at what we're asked to do here. First question, on a road bicycle, steep and winding roads require lots of braking. This braking produces a lot of heat and heats the air inside the tire. As the air heats and the pressure inside increases, I should say, if the pressure gets too hot, the tire may explode. What gas law explains this relationship between temperature and pressure? So if you think about a tire, whether it's a bike or a car, the volume doesn't change very much, so that's constant. So we're looking at the relationship between pressure and temperature. And if we remember back from our gas laws, that's Gay-Lussac's law, right? So we would use this relationship to solve this problem. So putting that to use, we just have to figure out, well, what are the initial and final states for this second problem? So 1b reads, at the beginning of the descent, the air in the tire is at a pressure of 110 psi and a temperature of 200 or 25 Celsius rather. So this is our P1 and this is our T1, right? Keep reading that problem. What is the maximum temperature the tire can reach if the tire tread fails at pressures greater than 160 psi's? So what is the maximum temperature is what we're looking for. So this would be T2 and this is P2. So remember, typically in a beginning chemistry class, we have some trouble with the algebra if we're trying to solve for something in the denominator. But remember, if these ratios are constant, then so are their inverses. So we can legitimately write it this way. So the algebra for this, if I want to solve for T2, would look like this. Multiply both sides by P2, that cancels, and I get this. P2 times T1 all over P1. So let's just put in what we know. I'm going to do it down here in the other corner here. P2 is 160 psi. That's the failing pressure. T1 is the temperature that we started out, which was 25 Celsius. We know we don't put it as Celsius. That's 298 Kelvin. And P1 is the starting pressure, which was 110 psi. According to my calculator, when I put that value in there, I get that the braking to give us this pressure in the tire, this failing pressure, would produce a temperature of 433 Kelvin. Okay, so the next question on the short answer is sort of a mastery chemistry problem in this case. You have to incorporate a lot of what we've already learned. So magnesium gas, when combined with hydrochloric acid, releases hydrogen gas according to the following skeleton equation. First, balance the above equation. Shouldn't be too difficult for us. The balanced equation would simply look like that, right? Everything is balanced. One magnesium, two hydrogens, two chlorines on each side of the equation. 2b, of the 5 types of chemical reactions we learned about last semester, what type is this? Well, just to refresh your memory, there was decomposition, synthesis or composition, single replacement, double replacement, and combustion. So let's take a look at this one. It looks to me like magnesium replaces hydrogen to give us magnesium chloride and liberates hydrogen gas. So this has got to be a single replacement. Now, the second part, how many moles of air are in a half liter flask at STP? And STP means 25 Celsius and 1 atmosphere, or 760 millimeters of mercury. STP, of course, standard temperature and pressure. So this is an ideal gas law problem, so we're going to definitely use PVNRT. PV equals nRT, right? And we're going to solve for how many moles of air must be in there. Now, air is actually a mixture, but the ideal gas law doesn't care. We're just going to solve for number of moles, period. So it will look like this, PV over RT. So the setup of PVNRT is pretty simple. We put in what we know, 760 millimeters of mercury for pressure, half liter volume, 298 Kelvin is the temp. So the only thing we have to figure out, right, is what's that value for R going to be? And of course, we're always given a table of values to look up. We're going to look then for something that's got these units. liters, and millimeters of mercury for their pressure. So we would do that, and we would find in our table that we have a value that would be about 62.4, and the units would be liters, millimeters, mercury per Kelvin mole. So when we do this calculation, we find out that the number of moles of air in this flask is pretty small, 0.019 moles of air. Alright, so the last problem here asks out, says 1 mole of magnesium and excess hydrochloric acid are added to the flask and quickly sealed. The volume of these solids add is negligible compared to the gas volume. What will be the new total pressure in the flask after the reaction in 2A is completed? Show work in units. So this is the reaction that we're starting with here in this case. The reaction shows right there. And we need to look at the stoichiometry. If I have 1 mole of magnesium, I expect 1 mole of hydrogen gas. So that makes the problem kind of simple, and we can do it in 2 ways. We now know that through Pivnert, the pressure will be nRT divided by the volume. And we can use Dalton's law to figure out, well, the pressure is a result of both of these mixtures of gases. The first one that we just solved, we figured out there are 0.019 moles of air in there, and this reaction is going to liberate 1 mole of hydrogen gas. So that means at the end, we're going to have 1.109 moles of gas. We're going to use the same value that we just used for R, 62.4 millimeters mercury liters per Kelvin mole. T is 298. We're taking some liberties here because this reaction releases some heat. It might actually warm up more than that, but we're going to say it's constant. And the volume is a ½ liter. So we find, assuming I put this into my calculator correct, we find the pressure is about 37,897 millimeters of mercury. If we keep in mind that there are 760 millimeters of mercury in the atmosphere, that's about, if we convert it, it's almost 50 ATM, so that's quite a bit of pressure. Okay, hope this helps. Good luck on your test.